Okay, so we should be live right now. Poor connectivity. Let's see. I don't know what I can do to improve these. Um, Hopefully it'll get better. So we're trying to solve exercise 4. Let me share. You guys let me know in the chat whether it looks smooth on your end, because YouTube is telling me the streaming is not going to look smooth enough at that point. Trying to think. Receiving and not receiving, not receiving smooth streaming. Come on, this should get better. Oh yeah, now it says it's getting better. So let's just share this. Let me share this in Twitter. Hey, live now. So hey, live now. Trying to approach exercise 4. Not much time, but we'll do my best. So, quantum computing tax. So you're not seeing any of these because I have it on my second screen. Let's tweet these. Let me put that in Facebook as well. I should have probably a faster and better way to share things. So let's post these. Post these. Cool. So I think we're good to go. We're good to go. Let me see. Can take a look at the. We're gonna start in a second, okay? So just like making sure that this is working smoothly for you guys at the moment, and it's gonna be available later on anyway, so it shouldn't be a problem. Stream health is excellent. Okay, cool. Let's start. I mean, let's just get started, okay? I don't have a lot of time, but there's 19 hours left. I sadly don't have enough time to approach the whole thing, but I think I have an idea on how to approach this exercise in a way that it's maybe not the best way to do this, because I think that's not going to work out easily, because what what most people do is, and I started already, so I started like earlier today, but I didn't have time to stream, so now I'm streaming it, and so let me put it this way. I think what most people will do, if you Google around unitary gate decomposition, there's probably a bunch of algorithms that you could apply to actually do these, but I think that's just not fun enough. Because I'm guessing there's just, some standard algorithms you can apply where basically you take the matrix and you kind of decompose it into submatrices and stuff like that. And then, because at the end of the day, if you go to resources in here, I think there's a pretty nice, create first content. I think there's a place with, where you can take a look at the actual gates. Blocks here, multiple qubits, gates. Where is these? Search gates. Or U3, I should search for U3 probably. Or the S gate. So here there's all the gates, right? And then it's pretty nice. So the U3, right, you can see here. Oh, you can't see the matrix in here. Used to be able to see the matrix, but anyway, there's just the U3 has got a matrix. And I guess you could try to, take the matrix that's given in the exercise and try to decompose it mathematically and then try to approach it. Now I'm going to try to do it in a bit of a different way. Okay, no, okay, so it's oh no, yeah. There's some other stuff that I've been playing with, but I'll explain you right now what I'm trying to do. So I'm trying to do it a bit like reverse engineering these, okay? So, and I don't know if this is doable at all this way, but I'm going to try to waste my time trying to approach it this way. So I hope maybe I get the badge of a failure, but at least was original. Okay, let's. The idea that I had this morning was the following. So, you basically, you guys, if you do this, you can see that there's this unitary matrix in here, right? So, if this runs, yeah. So this the matrix is 16 by 16, so it's big. So it's for 4 qubits. So the first idea that I had in mind is why don't we just try to, because with Qiskit you can basically, you can go and take this matrix and you can actually make a gate out of this. So I don't know if this is new or not. I think it's fairly new. Maybe not. I don't know. I'm not an expert in this, but the idea here is I made a unitary gate out of this unitary to try to understand how this unitary behaves when applied to certain initial states. So sort of trying to reverse engineering what it does to the different initial states to try to see whether we can reconstruct it. Because one thing that I realized is that if people have gotten like scores down to 45, I'm guessing this thing doesn't have more than like 2 or 3 control node gates, which brings the score up to 30 already. And so I'm guessing that's not, it's not something that it's, a super complex circuit. And if you have 4 qubits at the end of the day, I mean, to be honest, like how many? I mean, it can have many control node gates. I don't. So what we could do, what I was trying to do is the following. So first of all, what happens if I apply the unitary gate and I take a look at the block spheres, right, of our qubits? So if I do these, I get, let's see, what do I get? No, I don't want a Q sphere. I'm sorry, I was correct before. So, okay, so I get these in here. No, what am I doing? These in here, exactly. So this is something else I'll talk to you about now. So what I can read from that is that definitely, so those qubits are entangled, right? So there must be control nodes, because I was thinking it could also be that they just play with people, just playing with us, and so it's a really easy circuit, and there's no control node gates. But if they're entangled, right, because they are at the center of the sphere, it means that there must be control gates. Now, these control gates, how many of them? It has to probably, my intuition tells me it has to touch all the 4 qubits. So at least you have 2 control node gates. For example, between qubit 0 and 1 and qubit 2 and 3. And again, I'm trying to approach these from a total intuitive way. I'm not going to do any fancy decomposition, mathematical stuff. I want to try to see if this is solvable just by hand, like just by intuitively thinking about it, which it might not be possible, and maybe it's just not efficient enough even to turn it into an algorithm or whatever. But I don't know. I feel like doing that. I feel like testing my intuition there could be. It's probably an interesting thing to play with. But so I'm guessing this is it. Now, what I noted as well is that if you apply this unitary gate to the plus state, look what happens. Boop. You see. So basically now, this. Sorry, I'm getting confused. Let me just delete this because I was trying to reconstruct this here with U3 gates early this morning, and this is confusing me. So let me just remove these. Can I delete this cell? Cell, edit, delete cells. Okay. So look, this is super interesting, right? Because have you seen the solution of exercise 1? I don't know. I mean, I solved exercise 1. Maybe not in the best way, but I don't know. So I'm trying to basically, this is exercise 4, by the way, Karim. I don't know if you, or maybe it's got to do something with that. I don't know. What I'm trying to say is that, and sorry if I'm not looking at the chat very often. I'll try to look at the chat more often. I have it on another screen. So, so what I'm trying to say is that basically, if you apply this gate to to the plus state, it doesn't change any of the qubits. So this kind of tells me that this unitary operation could be approximated probably just with x rotations. Because if it doesn't do anything here, right, it means that everything that it's doing is around the x-axis. So that's definitely not affected. I will help me a lot. If you solve exercise 3, you will get an URL pointing. Ah, okay. Thanks, Asir. Thanks for that. Yeah, I got the URL. I got it. I saw it was a URL, but I'm not. I want to try to solve this without any clues. Okay. I know that I'm most probably gonna fail. I just wanted. Let me see if I can figure it out from just purely intuitively. Okay. Yeah, I remember. What was the URL? It was something. Yeah, there was a URL. You're right. There was a URL as a solution for exercise 3. But I want to try to see, because I have this intuition, I have this feeling that that I'm onto something here, and I might be totally wrong because I'm definitely a noob on these. So yeah, basically so it doesn't do anything on, and I'm sure I'm wrong, but let me try. Let me fail. Okay, let me fail. So it doesn't really affect that. So it seems like, and if you, I think if I just do this, right? So if I go into the minus state, I mean, that's obviously going to be the same. Yeah. So it stays there, doesn't do anything. So having said that, I have the feeling that if I am able to, even some intuition, then look at the symmetry of the matrix. Yeah, how would that help me? I don't know. I guess it's got to do with entanglement, right? Because my current thought process is, if I'm able to uncompute these, then I'd be able to approach it, right? So let's put it this way: if I so I apply this unitary gate to just to the zeros, like to the ground state as the initial state, right? So to figure out where the control nodes are, I have to try to unentangle these. If I try to disentangle these or unentangle these, I don't know what's the right word, then I'll basically have figure out where the control nodes are. My intuition might be wrong here, because if I go to Quirk, so if I do something like these, right? If I get into a bell state, right? So now my qubits are entangled because this thing, the vector is at the center of the block sphere. If I apply a control NOT gate, and now it's disentangled, right? But that also, the point is, the problem here is that I think if I for some reason apply it this way, it's also disentangled. But now, wait a second, is it just a global phase? No. Now you have a different state. So I can. The solution is for control. Don't spoil. Okay, don't spoil this. I know I'm not gonna get it. I just want to play with this. 5 U3s, really? I thought you would approach it with, yeah, 4 control nodes. Is this the best solution? Interesting. Yeah. I wanted to try to see if I could solve it this way, man. Yeah, let's see. I'm probably very late. Everyone's like laughing already at all these, but yeah, I don't know. I just wanted to put some of those ideas to test. Okay, so I want to see how far can I go. But thanks anyway. I want to see how far can I go with this. People, let me fail. Okay, I learn a lot from making mistakes. And I always try to do this from an intuitive perspective. I try to avoid them. I know that it's probably impossible to some extent, or maybe it's not impossible, but avoiding math, avoiding math is something that is definitely against any kind of cost efficiency. So yeah. let's see. My idea is if I manage to, can I disentangle that? If I can disentangle that, maybe I can. Because another thing, the reason I have all those here commented, I also found it interesting that if I apply, oh, that's the reason I have the power here. Sorry. So if I apply the power of this gate to the 8th, right? So if I apply this gate 8 times, I literally come back to the initial state. So that kind of gives me a bit of information on the periodicity or how this is called at this gate. Anyway, why am I applying it to the qubits in this order? I don't know. So, oh, but now they are good. This is gone. What does it mean that this is gone? Is it just a graphical error? I mean, it means they're still entangled, right? So if I do Cx between 0 and 1, what happens? 0 and 2, what happens? Okay, we're getting there. It's just disentangling a little bit. 0 and 3. It's probably a combination of, yeah, man, there's so many possible combinations in here, to be honest. That's totally disentangled now, is it? That's totally disentangled. If I now do a QC U3 rotation on, say, how does this work? Do I have, can I import NumPy? I think so, right? So from, how does it go? Import NumPy as NP. Can I do this? I think so. And then I just say, so if I do NP, if I, good luck, I will I come back later. Yeah, the cost is 45. I got 147. Okay, cool. So 45 is really the most optimal? Like, is it really the best score possible? Are we sure? That's pretty cool, though. I think I've disentangled qubit 0 now. So if I do these, so if I do, what is it, pi divided by 4 and n pi divided by 4, because this is, I think, where were those angles mapping, actually, to be honest, I don't know. What am I going to do now? Oh, I just moved it a little bit down. What is this angle? What? Should probably read the documentation. So this is around the z-axis. So we want z and y. So we also want. Okay, so we want these, but like -1 or something like this. No. Why is it not working? It's difficult to know where this thing is pointing, to be honest. So let me try to do one thing. So insert cell above. I'll just do a circuit of 1 qubit, and let me just see. So if I do p pi divided by 2, where is this going? So QC. Okay, so this is a Y rotation. Okay, and here I need a, so here I need a, the thing is, I don't know where this is really pointing at. Is this pointing at sort of the 45 degrees between the Z positive and the Y positive? I don't know if this is like that. So, or if this is, yeah, that's my guess. So I need sort of, what did I say? This is the, so this is, the y axis. I need the x axis, but I think so. This is the y axis, and this is okay. This has nothing, so this is the z axis. And this is what? Also has nothing? I think they don't map necessarily to each of those. Come on. So if I do these and these, where does this take me? Here. Okay, because I go like 90 degrees and 90 degrees. So if I want now to go back, okay, so what I should do is, okay, so I should actually do, yeah, so if I now do QC U3 0, 0 on 0, so this should take it to the minus state, I think. Yeah, okay, cool. And here I should do minus 1 times np pi divided by 2. So I should take it back to 0. No, why? Maybe it's with a minus here, I don't know. Then I should just do 3 times, like, so 3/4, right? So, no, what am I doing? So I want to go back here. I know, just, stupid, just n, just this. That doesn't work either? Why? So how do I do a y rotation with this? How do I do a y? Look, if I okay, so this takes me here, right? If I do this now, it takes me here. If I now do, maybe I can't combine them. I don't understand the U3. I don't understand the U3. Why would this work? Yeah, that works. Okay, so I can't, if I combine them, if I combine these two angles, it doesn't work. I don't get it. Okay, but let's see. Okay, so what I need to do for these to work is, so if I'm here, right? And now I've disentangled these, and let's assume I'm here. So the only thing that I want to do is I want to do n pi. So let's do this with first like np pi divided by 2 on the z-axis. That should take me right, perfect. And now I will do, okay. So now I will do this here, np pi divided by 2. So now I should be back at 0. No, oh, sorry. 4. It's a quarter of, yeah, it's a quarter, yeah. Good, so I brought that qubit back to 0. So it takes this qubit back to 0. But let's comment this out, because maybe I should first figure out how to disentangle the other qubits. Okay, so this is disentangled. What else do we do now? So what about, so this is between 0 and 2. 2 is still messed up, so I'm assuming there's something else with 2. So what about 1 and 2? Okay, no. What about 2 and 1? Yeah, baby. That looks good. I think that counts as disentangled because it's not really touching there, but it counts, I think. Okay, cool. Missing the other 2 now. So what about 1 and 3? So now there's going to be something like QCX 1 and 3, okay? Oh, almost. What about, okay, wait a second. They're almost, okay, so they got half disentangled. Why? Half disentangled. What about 3 and 1? Or did I just try that? No, it's the same. Okay. Okay. So this is pointing there. This is pointing there. 1, 3. 1, 3, baby. Okay, so the only difference here is we're getting them in different. Okay. Now it sucks because now I'm stuck. So how do I I need a fourth one. So because I know Karim said there's four control X gates. Is there really? Okay, let's see. What happens if I do, I don't know, QC? Okay, so this means that those two qubits are still entangled. One of those qubits must still be entangled with another one, maybe. I don't know, to be honest. What happens if I do 0, 1 now? Okay, no. 0, 3. No. 2, 3. I'm just shooting, 3, 2. Maybe. No. So I'm here, okay. So what if I do this now? So now I'm playing these things. Does this still work? Okay, so this is at 0 now. Now we want to take qubit 1, no, qubit 2, right? So this is qubit 1, qubit 2, so this is qubit 2. We want to do, so I want to do basically first a -1, no, so first I want to do a 3 times, for some reason the negative numbers don't work the way I expect them to work, so I should probably figure that out later. I want to go 3/4 of pi, 3/2 of pi, so yeah, 3/4 of the whole 360 degrees. And then I want to go 1/2. So that should take me qubit 2 to 0. Boom. Okay. And qubit 1 and 3. So for qubit 1, it should be the same, to be honest. But they're still half entangled. How do I solve that? And for qubit 3, I just need to, again, I don't know if that's going to work, right? Because I'm kind of reverse engineering these based on the ground state. So I don't know if that's something you can just like sort of extrapolate and say, okay, if it works this way, it also works with all the different initial states, right? So that it could be that it's all for nothing, or that I then have to tweak it to work on other input states. Maybe if I then, I don't know. So how can I disentangle that though? Okay, but for these, so for qubit 3, we need the same 3 times, yeah, but then we need 1/4. They're all pointing up, but these are still entangled. Can I apply now QC CX between 1 and 3? Oh. Oh. Ooh, maybe. I just got lucky. I don't know. Um, it's 4. So it's 4 control X gates, and I 1, 2, 3, 4, 5, 6, 7, 8. Okay, I got way more U3 gates, but I think I could or should be able to combine them. But now I still have to. So I still have to do two more for qubit 1. 2 more for qubit 1. Okay. So, and these ones for qubit 1 should be like should be. So it should be a half of pi for that, and then a quarter for these. Yes, boys, we have it. Yes, we have it. I don't know, to be honest, though, if this is the solution, right? Because, to be fair, let's try the following. So if I apply Hadamard and then I apply all this other stuff in here, is this gonna give me... No. That's not it. Okay, that's not it. So I made it work for I made it work for 0, but it doesn't work here because it's not giving me the same. If I apply Hanuman gates, oh wait a second, I should reverse that, right? I should reverse that. So actually, yeah, because that's the inverse. What I have here is the inverse, right? Because I uncomputed it, so I have to reverse that. No, how to reverse that? Okay, so maybe I what I go ahead and do is I make a new cell. Okay, so I uncomputed this now. So I'm gonna make a new cell, edit, insert, cell below. Okay, so now we gotta uncompute that, and I think in this case it's not. Sorry, we gotta reverse that. It's not enough for us to. It's not enough for us to just sort of invert the order, because here we've got rotations, and so the inverse of the rotations. So I think I can work it out. I think it's not complicated. So the inverse of the control gates are the same control gates, just in the opposite order. Okay. So, and then rotation is the same, but then I just have to change the angles. So this is the, so we're doing now, okay, so this is another cell. Forget about this. So I uncomputed, so this one uncomputes. Correct? Please? Please, please, please? Is this running or? Why isn't it running? Oh, God, what have I done? Here. U-gate, unitary gate. Okay, yeah, it's uncomputing. It just goes to the next cell, so that's confusing me. Okay, so it's uncomputing. And now, if I reverse the circuit, if I reverse the circuit, so how do I reverse the circuit? Okay, so this is the, can I make a comment? It's lagging a lot. I'm sorry, guys. I think so this is like inverse. So I know that I'm dealing with the right cell. And so what I want to do is I want to have these here. And so I'm just going to be Okay, so I'm going to be doing it like that. So this basically goes here. This basically goes here, and this goes here. Okay, so I've inversed that now. Should probably do operation by operation, to be honest. I have a tendency to be dyslexic with this stuff. Good. So it always goes to the top. It always goes to the top. Here, oh god, no. Here. Here. I don't know. I don't think this is gonna work out, to be honest. That will be too easy. Or I'm just too optimistic. I don't know. Like, I don't even know how the U3 gate works, man. It's just rotating, right? But what are those angles? I think they're just like there's like a matrix there with a cosine and a sinus or something, and then that's kind of where the values go. Those are not angles in the block sphere, that I know. Or I think they are actually, or some of them are. I don't know. I hope that I'm getting these correctly. So this has been purely reverse engineered by trying to uncompute what the gate does to one state. I don't know if this is going to extend to any initial state, okay? So this might be a total loss of time. But if so, I mean, at least I would have learned something. So how can I check that? So it's CX202113. CX202113. What? What have I done? Oh, man. What? Why? I think I'm stupid. Have I just I think I'm stupid. Yeah. So let's start from scratch, okay? Please don't blame me for this. Don't make fun of me. So we want to do it this way, okay? So this will be easier this way. So we're just inverting the order. We're just inverting the order. This is not rocket science. I mean, I don't know. Is this really the way that like if this really works, I'll be quite surprised, to be honest. I guess it's impossible to turn that into an algorithm, though. I mean, it's kind of funny because I'm using, to do that, I've basically turned the gate into an actual gate in Qiskit. And so by doing that, I'm assuming Qiskit is running anyway their own decomposition algorithm in there, right? So, okay, so now this is this, but I'm guessing this is not we're not done yet, because what we need to do is we need to basically invert the angles in here, right? And so if I go back in my test one here and I just say, okay, so the inverse, so if I go and have these, right? I think it's not optimal that I've used as many, so I'm only using one of the parameters in the U3 gate, but I think it's gonna be easier to, it's gonna at the end be easier to Uncompute. So if I do these, I get basically, sorry, QC Automart 0. So this kind of turns this way. So the inverse of these is why isn't this working this way? Oh yeah, it is. Okay, so the inverse of this is just the minus here. Okay. So whatever I have that, I just have to add a -1 here, times -1. So times -1, times -1, times -1, times -1, and we're done, right? Because let's see, if I do 3 times, so where does this take me? Here, right? If I do -3 times, takes me there, correct. Okay, so it looks like just inverting the sign should be enough. If I keep the angles being just 1, the parameters used being 1, I guess that should be enough. If I do here np pi divided by 2, right? So I get these. If I do -1 times that, I go back. Okay, so that works as well. So basically the same story goes here. Now my question is, does this behave like the gate 400? It should, but that should be my first test. So we don't want these here. No, 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 no. Oh, I told you. I've been doing this in the wrong circuit. Damn it. Okay, but I can try to do these. So if I apply this gate, no, 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 let's not mess up, okay? So, come on. So, this is me like half an hour solving the problem, half an hour cleaning up my mess. Because I am really smart. Okay. Let me check. That's still uncomputes, right? Okay, perfect. So all I need to do here is I need to add -1 times everything. Da, 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 da. Oh, here we can just add okay, but that works as well. That works as well. That works as well. That works as well. I wonder whether you can just combine, like, cannot you just combine the parameters? Because that would be 1, 2, 3, 4, 5, and then I'd have actually a yeah, kind of the same thing what Kareem is saying. Anyway, let's try this out. So I've got this in here. Now, what I was trying to do, so this is the inverse. So in theory, the inverse of my computation, which is kind of is supposed to be the gate. So if I apply these to this circuit with the state 000, should give me the similar result. Yes. Oh, I love this. I think I figured it out. And now this should give me... Oh, damn it. No. No. That's not it. Because that should tell me... That should give me... There should be these, right? So if I apply the unitary, so how can I comment multiple lines? No. Can I comment multiple lines? Python comment multiple lines out. Why is it lagging so much? Come on. Multi-line comments. Oh, come on. Free up some storage. No, thank you. Okay, like these. So if I do these and I comment down here, so I'm commenting all these and I'm just applying the unitary gate first. Cell 64. Something's off in here. I'm just, there's too many cells and I'm messing up too much. But this seems like, yeah, it kind of seems the same, but it doesn't behave like I expected when I applied Hanuman Gate. So if I'm here, what I wanted to try. Okay, no, actually that was correct. I wanted to comment all these, and now I wanted to apply the unitary gate. So here it's the quantum circuit. I get the unitary gate, and I just apply the unitary gate. And this is, yeah, this is these. And if I apply a Hadamard gate before the unitary gate, then it stays like that. Whereas here, if I apply a Hadamard gate, I get the same. But if I apply a Hadamard gate, why is it going so slow? If I apply a Hadamard gate first, I hope the stream is going well. Yeah, so if I apply the Hadamard gate here first, and this is cell 70. Is this the cell number, or is this just the... Okay, so I'm getting something that's not what I want. So this is definitely not the best way to do that. But I was kind of happy because it was really close to, but I can try. I mean, let's see. Okay, so let's try to submit this circuit. So we have QC here, right? So if I apply this circuit here, that basically gives me these. If I apply check circuit, okay, that's not right. Yeah, it differs. Maybe there will be a way, maybe there's a way that I can tweak that, right? Come on, but you have to admit it was a good idea. If I combine those operations, am I getting... So if I combine those operations, those things should work, right? So if I combine those operations, so I have less U3 gates. Again, I'm not looking at hints. I don't want to take a look at the hints. I just wanted to know whether my intuition was right, okay? And I think it is somewhat right, but I still would need to adapt it to... I would still need to adapt it to other inputs, right? So if I do this, is this gonna give me the same circuit? Yeah, okay. So I can combine those, and now I have literally just like exactly what Kareem said, right? Like four control X gates and 5 U3 gates. But that doesn't work for Hadamard gates. Sorry, it doesn't work for the Hadamard thing. So if I apply now the Hadamard gate, because the problem is that if I now tweak it for that initial state, then I'm gonna probably lose on the other state as well. Because as I said, I had the impression, based on my initial thoughts, that the rotations should only be Z rotations because they don't affect. Like if I apply the unitary gate to the Hadamard to the plus state, it doesn't change it. This must mean that they are all rotations around the x-axis, but it's not. It's not good. It's not good. What could I do next? What could I do? How could I fix that? Any ideas, people? Or did I go down the wrong path completely? Come on. Why not? Let's try to correct that. If I try to correct that now, I should save this first of all. So I should save the circuit. Does the order of the control X gates matter? So if I have these here, I'm getting that. If I move this one here, yeah, of course it matters. Maybe my mistake was okay, but let's try maybe what happens here if I apply these to, say, the for example, one of those other states along the y-axis, right? So I do QC and now I do S range 4. So if I do these 0 to 3, so what happens? So I get these kind of entanglement. Okay, so this kind of stays. So it's like this. So it's left, down, down, left. And if I apply the same here, am I going also in a completely wrong way, or yeah? To be honest, it seems I just have to. No, I don't know what to do. I don't know where to take it from here. It definitely differs. It's funny though that I'm getting the same amount of gates that Kareem is saying. It was probably just a coincidence. And I haven't, again, I'm trying to re-engineer that. If there's anyone who's joining late, what I just try to do is I try to basically, so I got the gate, I put the gate, I got the matrix, I loaded it into a unitary gate here exactly. Run that gate against the 0, 0, 0, 0 state, and then try to basically uncompute it. Because my idea was if I manage to uncompute it, then I reverse the uncomputation. Well, that will basically give me the U gate. But it only gives me a U gate that acts the same for the for the 0, 0, 0 state, which is obvious, right? I was just thinking whether that would extend to other initial states, but it doesn't. And so we kind of need to find an equivalent in there. And that's tricky. And that's kind of tricky. Maybe if I would manage to, so what am I doing? So if I have the Hanuman gate here, so I should kind of like from here, okay, Just a thought. It's almost about an hour, so I'll probably go. Probably finishing soon. It was a good. It was a good try. Okay, so I would still need to basically do some unentangling between 1 and 3, I guess. What if I do 3 and 1? Right? Okay, because now we want to basically take everything to the plus. So we want to take each qubit to the plus state. And so I'm assuming that's pointing down here. I think that was easier to see. Is that easier to see? Kind of. Because now I just would say qubit 2 is easy, right? So qubit 2 needs basically a just like a pi rotation here. Yeah. Qubit 1 needs what does qubit 1 need? So I'm trying to compute this now. So qubit 1 needs a quarter. So qubit 1 needs np pi divided by 4. Yeah. Qubit 0 needs basically n divided by 2, and then I'm doing again 1 by 1, then I can combine them easily, right? And I can then combine everything easily, I think. 0. Especially those rotations, would they be combinable somehow? I don't think this is going to take me anywhere, by the way. If that fails, I'll just stop here. But so what I was going to say, and now I need, so this is 0, and this is basically 4. Correct? Correct. And for qubit 3, I also need 2, where I'm basically doing what? I'm doing 3 times these, and that's correct. I think that should be fine. Okay, cool. If I now do -1 times everything, so I do the inverse here on the spot, and then I basically go and put this here. Well, my guess is that now I will have my guess is now, if this just works well, I will have correct for plus. So I'm guessing that now, no? Why not? I just don't get it. Oh. So those should probably be at the beginning? Or what? I guess. No. So what am I doing now? So I uncomputed these. So this is the gate, but I want to basically add this correction. And so, no, sorry. Okay, let me go back. I didn't have to invert that. That's kind of, I'm trying to kind of correct for what's, so that's correct for plus, but that's good enough. So now that tells me this is these. And then so the problem is that if I now uncomment that, I'll probably spoiled everything. Okay, maybe not that bad. It's probably not the same. I don't know. I can try to submit these, but I'm assuming that's not going to be the same. So okay. So I submit. I go, and now I submit these. It's not probably going to be the same. No, it's not right. Okay, it's not right. Okay, I tried at least. I just ran out of time now, so it's a pity. But I thought I had a good idea. Yeah, I'll try to come back to these. I'll try to actually solve these because there must be. I wanted to try to see if there's a way, that you can approach these types of problems intuitively. So I'm still streaming. Let's see if this is still streaming. It's back at excellent. Yeah, okay. Anyway, I got a. So I could have solved that the sort of the brute way, which is just apply one of the existing algorithms. Maybe there's a way you can do that intuitively by taking a look at the matrix. As I said, as Karim was saying, if you take a look at the symmetry of the matrix, you probably can know where the control nodes are. It's like I feel I'm close to it, but I just really run out of time. So anyway, oh no, that's not right. Okay, no. Okay, the cost is 45. Circuit stats, U is the reference unitary, V is yours, and the global phase has been removed from both. Cost is 45. Something's not right with your circuit. The circuit differs in the unitary more than 001. Okay, so the cost is 45, but the unitary differs. Okay. Yeah. Anyway, we'll leave it here, guys. It was nice trying. I definitely want to go and try to sharpen my intuition here. There must be a way that I can do these. What's the intuition behind decomposing a unitary gate? I think I'm going to be doing some series based on these as well, because yeah, it's fun, and I think it's good for sort of the working out the first principles, trying to understand a bit more how to control NOT gates play here with entanglement and all that stuff. So, but I'm going to be finishing here. Thanks, and yeah, it was fun. It was really fun. Cool. Have a good day.